Welcome to this presentation on the Drainac 3B Online Freeness Analyzer. This presentation is concerned with troubleshooting the Drainac Air System. Okay, we'll talk a little bit about the Drainac Air System, the requirements for the air system. I'll give you a description of the system. I'll describe what normal operation looks like and also common problems and solutions to those problems. All right. The Drainac Air System is basically designed to enable the system to take and clear samples of stock from the stock line. It must be maintained for proper Drainac operation. So what are the requirements for the air system? Well, you need a source of instrument quality dry air with a minimum pressure of at least 10 psi above maximum expected stock line pressure at all times. It must be instrument quality, it must be dry air, and it must have a minimum pressure of at least 10 psi above the maximum expected stock line pressure. The instrument quality dry air is necessary to ensure the robust and reliable operation of the precision pneumatics. Moist air will damage these components over time and result in unreliable performance. It basically takes a precision component and turns it into a boat anchor. The minimum air pressures are needed to ensure that the stock doesn't back up into the system. These events, I call them stock blowbacks, will damage the precision pneumatics considerably and rapidly shorten their life. Radically shorten their life. All right, so let's take a look at the Drainac Air System. You have a supply of air coming into a filter regulator on the left-hand side of the Drainac cabinet. This is the pneumatic air supply for the various components in the system and is distributed throughout. So, pardon me. So that filtered dry air goes to both the differential pressure relays, the intake and the exhaust regulators. It also goes to the pneumatic booster on the riser as well as the pressure transmitter on the side of the riser. There's a picture of the regulator. There's the intake and exhaust regulator, and that's what the booster looks like, and there's the PMC. Okay, the PMC basically will take that air, we'll use that pneumatic air supply to constantly monitor and transmit pneumatically the pressure of the stock line back to the system. So that stock line pressure signal goes to the reference ports of both the differential pressure regulators, the intake and the exhaust, as well as one side of the differential pressure gauge. And that's what the differential pressure gauge looks like. Okay, the intake and exhaust regulators are set as part of your commissioning effort to specific pressure levels, either above or below the stock line pressure. And the outputs of those regulators are sourced to a solenoid valve. The electronics will select which of those pressures gets transmitted to the riser assembly. One leg will go back to the differential pressure gauge to complete that circuit, as well as go to the booster assembly. The booster assembly then retransmits that pressure to the analysis tube itself. Okay, looking at the Drainac enclosure, here are the various pneumatic components. You have the exhaust relay up here, the intake relay here, the three-way solenoid here, and the differential pressure gauge here. Normal operation. If you were to walk out to the Drainac, this is what you should see. You should see the stock basically moving up and down in the system, followed by a healthy, or preceded by a healthy flush. Oops. If you don't see this, something is up. You need to check out why this isn't happening. Okay, main causes of problems. Failure to maintain the plant air supply pressure levels. As I mentioned, Drainac requires that the air supply pressure levels are maintained at a minimum of 10 psi above the maximum stock line pressure at all times. If you don't do that, or if your pressure levels aren't maintained properly, there is no way for the Drainac to prevent stock from backflowing through the air system. When this happens, the precision pneumatics will be flooded with stock filtrate, liquids, debris, fiber. This will inevitably lead to component corrosion and sharply reduced, if not entirely eliminated, functionality. And components that should have lasted you a year may have a radically shortened lifespan, measured in hours or days. If you don't maintain the quality of the dry air, the air supplies need to be instrument quality with a dew point of -40 degrees at all times. If you use moist air, that will accelerate corrosion of those precision pneumatics as well. And again, shorten component life. So what happens when you have a loss of air pressure? Well, stock will start working its way back through the system. It'll hit the booster, the PMC, the two regulators, the solenoid valve, and the filter regulator. It's bad news for everybody. Here's what it looks like when you have problems with components. This is a disassembled booster assembly. You can see significant corrosion and debris. This booster wasn't working anymore. This is another, actually this is the bottom of an intake regulator, and you can see that it is just badly corroded. When you lose air pressure and you get a stock blowback, there are some things that you can see immediately. One of the first things that I tend to look for is this little loop of tubing inside the Drainac enclosure, connecting the intake regulator on the right with the solenoid valve on the left there. When you get a blowback, this inevitably will get discolored because it captures a lot of debris. This is pretty much diagnostic of a backflow event. When that happens, you've had one of them, and chances are you're going to have to start replacing a lot of pieces, like the intake regulator and the solenoid valve. This should be clear tubing, more like this little piece right here. Just to illustrate that point again, here you have nice clear tubing. Here you have tubing that has been flooded with debris. Amber discoloration of the clear tubing is normal and not a reason for any concern. Black or dark gray is indicating that you have debris inside that tubing. Okay, keeping on this topic of inspecting tubing, this is a Drainac that experienced a lot of problems, not the least of which was a backflow event. Here's that little loop of tubing I mentioned earlier. You can see it's dark black. Here's another one that's pretty dark black. Another one still dark black, dark black. All this tubing has had stock in it, which means that the solenoid valve and both regulators probably need to be replaced. Okay, on the riser itself, there is a little fitting called a strainer. And this strainer is there to catch debris. This is an easy thing to inspect. It just comes right off. Of course, if it's been sitting in the mill for a while, you might have to really put some elbow grease into getting that hex nut off. But when you get it off, you can get the little cylindrical screen out of there and take a look. Here's an example of one that has just been absolutely clogged solid with stock. So this is definitely something you want to inspect on a regular basis. Okay, that's pretty much it. We're always happy to answer any questions that you might have. Please give us a call at 504-833-6381. Our email address is sales@tico-inc.com, and of course you can always reach us on the web at www.tico-inc.com. Thanks very much for your attention, and please don't hesitate to call us. We're here to help you.